friends, in this video we are going to study about the ultrasonic flow meters. Here we will study the principle of working, construction, the types of ultrasonic flow meters, its advantages, disadvantages and its applications. So let us start with our topic. The ultrasonic flow meters, they are the devices or instruments which are used for the measurement of flow of a liquid, or we can say they measure the velocity of a fluid which is flowing in a pipe or some vessels. So these ultrasonic flow meters, they uses the ultrasonic waves for the measurement of flow rate. So these methods or these flow meters are going to use the ultrasonic waves to determine the flow or velocity of the fluid which is flowing in a pipe. Okay, now these ultrasonic flow meters, they are using the ultrasonic waves. So these ultrasonic waves are in the frequency range above 20 kilohertz. If we see the hearing range of the humans, so hearing range is from 20 hertz to 20 kilohertz. So the waves which are above the 20 kilohertz of frequency, they are called the ultrasonic waves. So ultrasonic waves, cannot be heard by the humans because humans hearing range is from 20 hertz to 20 kilohertz. Now take the example of the animal bat. We all know that bat cannot see. So how the bat, it determines the distance or determines that if any object is or obstacle is there in between it. Okay, so what this bat does, this animal also uses the ultrasonic waves. The bat emits ultrasonic waves, and when these waves strike any object or any obstacle, it is going to hit the object and then reflect back. So the time taken by the ultrasonic waves to get generated and then strike the object and return back, this time is calculated by the bat to determine the distance between the bat and the obstacle. So if the bat is getting to know that this much time is taken for the waves to strike and then return back, it can determine the distance and it can get to know that what is the location of the object from the bat itself. So this same principle is being used by the ultrasonic flow meters also. Here the bat is calculating the transit time, means the time taken by the waves to strike and to return back. So this time is called the transit time. So these flow meters also use the same principle to find out this transit time, and this transit time is used to determine the flow of the fluid. Okay. So let's see the principle of working of these ultrasonic flow meters. Now the ultrasonic flow meters which are using the principle of measuring the transit time, they are known as the transit time ultrasonic flow meters. Because they determine the flow by measuring the transit time. So they are known as the transit time ultrasonic flow meters. Now in these flow meters, they send and receive the ultrasonic waves. So in these transit time ultrasonic flow meters, there will be two transducers. One transducer is in the upstream and other transducer is in the downstream. Okay. So both these upstream and downstream transducer, they are going to send and receive the ultrasonic waves. Okay. So the transit time is then calculated, and under no flow conditions, same time is taken to travel the upstream and the downstream. Let us see a figure so that it will be clear to us. Suppose that this is the pipe and the fluid is flowing in it. Okay. Now in this pipe we will be having two transducers. This is transducer 1, this is transducer 2. Upstream is the direction in which the fluid is flowing, and downstream is the opposite direction in which the fluid is flowing. So this is upstream and this is downstream. So these transducer, they are going to send the ultrasonic waves. This transducer 1 is going to send the ultrasonic waves to transducer 2, and transducer 2 is also sending the ultrasonic waves to transducer 1. So this is the upstream calculation and this is the downstream calculation. Now when the fluid is not flowing, it is still. So under the no flow condition, same time is taken to travel the upstream and the downstream. So if we calculate the time taken by the waves to received by the transducer, sent and received by the transducer, so same time is taken in the upstream and the downstream. But when the fluid is flowing, so we can say under flowing conditions, the time taken by the ultrasonic waves to sent by transducer 1 and received by transducer 2, that is in the upstream condition, less time is taken, while in the downstream condition, more time will be taken. Sorry, in upstream direction, the wave will travel slower, so it will take more time, while in the downstream, the wave will travel faster. So here it will take more time and here it will take less time. Okay, so under the flowing condition, there will be the difference in the transit time in the upstream and the downstream condition. So we are going to measure the difference in the transit time, and with the help of that, we will be able to find out the flow or the velocity of the fluid. Now, as this fluid is going to move faster, the difference between the upstream and the downstream conditions, it also increases. So when the fluid it moves faster, the difference between the upstream and the downstream time increases. Now why there is a difference in the time taken under the flowing conditions? This difference is due to the Doppler's effect. So due to Doppler's effect, there will be a difference in the time taken under the flowing conditions, and as this flow of the fluid is becoming faster, the frequency shift is also increases linearly, and as the frequency shift is increasing, the time taken or the difference between the upstream and the downstream times it's also increases. Okay, so this principle is being used by the ultrasonic flow meters to find out the flow rate or the velocity of the fluid flowing in the pipe. So let us now see the construction and working of the ultrasonic flow meters. As I have said that in the ultrasonic flow meters there will be two transducer. These transducers are going to send and receive the ultrasonic waves. So here in the construction, it will consist of two transducers, which are basically two piezoelectric crystals. Okay, so these piezoelectric crystals are going to act as the transmitter also and as the receiver also. They are going to transmit the ultrasonic waves and also they are going to receive the ultrasonic waves. So these flow meters consist of two transducers which are two piezoelectric crystals. These piezoelectric crystals or transducers, they are located in the pipe. Okay, they will be planted in the pipe and they are kept at a distance from each other. If we see the diagram, so this is the pipe in which the fluid is moving with the velocity v, and these are the two piezoelectric crystals. They are acting as the transmitter and the receiver. D is the distance between these two crystals. Now, if we find out the time taken by the ultrasonic waves to get received by the transducer and get reflected back, the transit time, if we calculate upstream and downstream, then we will see that so when the transmitter it emits an ultrasonic wave or ultrasonic pulse, this pulse is received by the receiver at a time del t later. So del t is the time taken by the ultrasonic wave to get received by the receiver. Okay, suppose that at a 5 minutes delay means at suppose that at 11 o'clock this pulse is being generated, at 11:05 it is being received, so 5 minutes of delay is there. So when transmitter emits an ultrasonic pulse, it is received at a time del t later. Now when this is in the direction of the flow of the liquid, the time will be more. Okay, and when it is in the opposite direction in the flow, that is in the downstream, the time taken will be less. So in the upstream and downstream, So transit time in the direction of the flow, that is in upstream, is given by del T1 equals to D upon C plus V. C is the sound of propagation plus V is the velocity of the liquid, that is the linear velocity. D is the distance between the transmitter and the receiver. So it will be added in the upstream, the velocity they get added, so D upon C plus V. We are using the formula velocity is equals to distance upon time. Okay, now the transit time in the direction opposite to the direction of flow, that is in the downstream, T upon C minus V. Here the velocity will be minus, okay. C is the velocity of sound propagation. V is the linear velocity of flow. And D is the distance. So this was about the transit time. Now comes the phase shift. Similarly, when a sinusoidal signal which is of frequency f hertz, it is traveling in the flow direction, it is going to has a phase shift of given by del phi 1 equals to 2 pi f d upon c plus d. And if it is traveling in the opposite direction, then it will have a phase shift of 2 pi f d upon c minus v. This will be in the radians. Unit of phase shift is in radians. So this is the phase shift given when a sinusoidal signal is traveling in the direction of the flow and in a direction opposite to the flow. Now to measure the velocity or the flow rate, we can measure it with the help of measuring the transit times also and by measuring the phase shift also. So by using both these methods, transit time measurement and the phase shift measurement, we can measure the flow rate or the velocity of the fluids. Now in the diagram we have seen that in the ultrasonic flow meters we are using the transmitter and the receiver. Transmitter is transmitting and receiver is receiving the ultrasonic waves. So these transmitter and receiver, they can be either inside the pipe or they can be either outside the pipe. So they are either interior or exterior to the pipe. When they are in the interior side, then they are immersed in the liquid. When they are exterior to the pipe, they are pressed to the walls of the pipe. Now, as I've said that we can measure the velocity by measuring the transit time. So, in both the times we have calculated del T1 and del T2. That is the time taken in the upstream and time taken in the downstream. So, difference in the transit time is given by del T1 minus del T2. Okay, or we can say del T2 minus del T1. Okay, whichever is greater, we can find out the del T, which is given by do 2 dv upon c square minus v square. Okay, so by using this formula we can find out the velocity or the flow rate. If the sound of propagation is very much greater than v, that is c is very greater than v, then we can neglect this v square and the formula is reduced to 2 dv upon c square. So velocity, you can see that it is directly proportional to the difference in the transit times. Now, we have seen here that in the ultrasonic flow meters, we can either measure the transit time or we can either measure the phase shift. Now, frequency-based systems can also be used here, that the frequency is also going to change when the flow rate of the liquid is changing. So, based on the frequency, we are having a different arrangement in the ultrasonic flow meters. Let's see the diagram for that. So this is the arrangement for the frequency operated the ultrasonic flow meters. Here you can see that we are having 4 piezoelectric crystals. 2 are acting as transmitter and 2 are acting as the receiver. So there are 2 combinations of the transmitter and the receiver. This transmitter is transmitting the ultrasonic waves. This is receiving. This transmitter is transmitting and this is the receiver for it. Now both these transmitter and receiver, they are connected with an amplifier for the amplification of the signals, and d is the distance between the transmitter and the receiver, and theta is the angle from the center of the fluid. Because I have said that as the flow rate changes, the frequency shift also increases. So this is based on the measurement of the frequency difference. Here we are using two self-excited where the receiver is providing the feedback to the transmitter. Okay, here also you can see that receiver is providing the feedback to the transmitter. So there are two self-excited oscillating system where the feedback is provided by the receiver to the transmitter. Now the pulse repetition frequency in the forward 1 by del t1, because frequency is inversely proportional to the time. So pulse repetition frequency in forward propagating loop is 1 upon del t1 and in backward loop is 1 upon del t2. Now if we find out del t1, it is d upon c plus v cos theta, because here we are taking the sine and the cos components of the angle. So d upon c plus v cos theta, and del t2 is d upon c minus v cos theta. So F1 will be 1 upon del T1 equals to c plus v cos theta upon d, and F2, which is 1 upon del T2, is c minus v cos theta upon d. Now if we find out the difference in the frequency, which is del f equals to f1 minus f2, then c plus v cos theta upon d minus c minus v cos theta upon d. So when we will solve this, we will get 2v cos theta, because c and c will be cancelled, minus sign will be there, and this minus will be changed into plus. So it will be added. You will get 2v cos theta upon d. So from this equation, you can see that the difference in the frequency is directly proportional to the velocity. So if we are measuring the difference in frequency, we can measure the flow rate or the velocity of the fluid. And also you can see that this equation is independent of this term C. C is not present here. So if there are any errors in this C, those errors will not occur in the measurement, whereas in the earlier transit times and the phase shift measurements, those terms were involving this C term also. Okay, there we were having the transit time, that is del T equals to 2 dV upon C square. So if there is any error in this C, it is going to affect the measurement, that is transit time. Now here the frequency del F, it is independent of this term C, so it is not going to affect the measurements. So in this equation, you have seen that the output is linearly proportional to the flow velocity. So this was the two arrangements which are used, two types of ultrasonic flow meters. In the first type was used for the transit time calculation, and the second arrangement is used for the measurement of difference in frequency. Now let us see some of the advantages and disadvantages of the ultrasonic flow meters. If we talk about its advantages, we have seen that there is no obstruction in the flow of the liquid. The transducers are present outside the pipe, and all the instrument parts, they are all outside the pipe, so they are not affecting the flow of the fluid. So that is the main advantage of this ultrasonic flow meters. Also, the ultrasonic flow meters, they are insensitive to the variations in the viscosity, density and the temperature. There are no moving parts involved, so there is no problem of friction. Also, there is a linear relationship between the input and the output. So these are the advantages of the ultrasonic flow meters. If we talk about the disadvantages, they are complex, and high cost. means they are complex and expensive instruments. So these are the advantages and disadvantages of the ultrasonic flow meters. Now let us study some of its applications. Now ultrasonic flow meters, they are generally used to measure the flow rate of the liquids. But here only those liquids which can allow the ultrasonic waves to pass through them, only those liquids velocity can be measured. Examples of such liquids are water, molten sulfur, cryogenic liquids, and chemicals. So only those liquids which can allow the ultrasonic waves to pass through them, only their velocity can be measured. Also it can be used to measure the velocity of the vapors and the gas. So not only for the liquids but also for the vapors and the gas flow measurements, the ultrasonic flow meters can be used. But also there is only one limitation, that the liquids and the vapors and gas, they should allow the ultrasonic waves to pass through them. They should not be then absorbing the ultrasonic waves, otherwise the measurements will be inaccurate. So we have to be careful, because the fluids that do not pass the ultrasonic waves, like the slurry in the industries, they are going to limit the penetration of the fluids into the of the waves into the fluid. If we talk about the industries where the ultrasonic flow meters are used, then industries like power industries, chemical industries, food and beverage, pharmaceutical, metals and mining, oil, gas, water and wastewater. So in all these industries, the ultrasonic flow meters, they find their applications, their use. So in this video, we studied about the ultrasonic flow meters, which are used for the measurement of the flow or velocity of a fluid flowing in a pipe. We saw its principle, its construction, its working, and its applications, advantages and disadvantages. So I hope that this topic is now clear to you. Thank you.